Hey guys, Jordan here from VFX Vault again, and today we're going over an array-based line. So what we can do using Niagara is we can make a line that goes through as many points as we need, as big as our array can be, and we can use it for something like this, like a waypoint system. So we can have one point here, 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 and here, and then we can add as many points as we need to make the line as big as we want, have as many stops as we want. So see, if we come down into the level, the line is going between each of these blue boxes, but it doesn't have to be attached to a box. It can just be anywhere in the level that we set the position. And this could be something like a waypoint system that a player could follow, or maybe a box, you know, around a player with a certain amount of corners, or anything that we need it to be. So let's get into it. First things first, let's make our Niagara system. We will just go with a directional burst and go ns array based line. Open that up, bring it over here. So we need to, we'll just set it to say 100 points for now. Set it to infinite, so just so it's looping. Set the particle lifetime just to 1 so it loops nicely. Uniform size of just 20 for now. Get rid of velocity, don't need that, don't need gravity, don't need drag. Get rid of all of these, just those two, and we'll save that. So the way we're going to set this up is we're going to have a blueprint that uses the construction script, so we can set an array of vectors that we're going to feed into our Niagara system. So we need an array, so let's make a new positional array. So this is the array, and we'll just call it position array, that's fine. This is the array that's going to hold all of our points on our line. We save that, and we'll just close that for a second, and now we need a blueprint so that we can easily sort of access and update our array in the level. So we go BP underscore array based line. Now we could do it by dragging this into the level and adding the position, but it's just a bit easier to copy the positions from each box as a vector into a construction script variable rather than it is into the positional array on the Niagara system. So save this and we open it up. So let's open, so we've got our new blueprint here. We come over to the construction script and we need to drag our Niagara system in. Cool, so we drag our Niagara system out and we go position, so set position array, and you can see it's expecting a vector array and a name. So remember, we called it position array. We'll just plug our construction script in here. And then for the array data, we can right click here and go promote to variable. And we'll come down here and just rename this position array. And we make this instance editable so that when we drag it into the level, we can actually edit each entry in the array. So we save that. And then put this on my other screen. And we can drag our array-based line blueprint into the level. That's good. So next we need to give it the points from each of these cubes. But before we do that, actually, we're going to set up the Scratchpad module here in Niagara. So we could do it as kind of like its own parameter, but then it would be quite big and quite convoluted and just make a big stack. So it's a bit tidier to do it as nodes. So we can go new Scratchpad. So in our new Scratchpad, first we need to set an input. So we're going to need our positional array. So go position array. So we can get an input type of position array. And then next, we're going to need a few things. First, we need to get, so we're going to need to get values from this array. So we need to get the starting, the value of the current point that we're on and the next point that we're targeting. We need to get the length of the array, so we can iterate sort of through it. And we take the length and we minus 1, so that if we have sort of 2 points in our array, it only needs to go from 0 to 1, of course. So we just minus 1. Next we need our normalized execution index. We've got a normalized execution index here, and we multiply that against our length of our array. Good. Then we just move this over here, make a little bit of extra space. So we need a floor and a seal. Cool. So we're going to take this. So imagine we have an array that has 5 points in it. So we take those 5 points, we subtract 1, so now we've got 4. We multiply it against our normalized execution index. So now we've got a number, depending on how many particles we have, we've got a number that goes from 0 to 4 if we've got 5 points in our array. So we can say, as those points count up, as our normalized execution index counts up, we can say we can tell if it's between sort of 0 to 1 or 1 to 2 or 3 to 4 by using floor. So if it's say 0.5, we know that its starting point is going to be 0, and we know that its ending point for this segment of the line is going to be 1. Okay, so we need to convert that to an integer because we're getting an index. So we go int, we go convert, or is it float to int? No, let's just go convert. Cool, so plug that in here, plug this in here, and make sure that we connect the little line in the middle. We can copy that, plug it in here, put a little reroute node here so that we're getting the value here. Awesome. So that's good. So remember, as we count up our line from 0 to 4 or 0 to 5, we're getting which segment of the line that our particle is on. Then we use a frac. So remember, we're going 0 to 1, 1 to 2, counting up depending on how many particles we have, and we can use that fractional part of the number to lerp between these two positional values. So from say 0 to 1, or 1 to 2, 3 to 4, we can lerp, and then we can plug that into our position. So if you're struggling a bit to understand exactly what's going on here, I'm going to just loosely explain it. So we have, imagine here that we have our positions in our level. We've got point 1, point 2, point 3, point 4, and of course this is 2D, but it's the same for 3D. We have our normalized execution index. Remember, for every particle, it goes from 0, ... counts up to 1, depending on how many particles there are. Let's make this just a little bit smaller. And we take that normalized execution index and we multiply it by our number of points minus 1. So our number of points is 4 minus 1. So we take that 0 to 1 and we multiply it by 3. So we have 0, 2, 3. So what we're doing then is we're flooring depending. So let's imagine we have now our line from each point. So now imagine our particles sort of count along that line. So from here to here would be 0 to 1, and then again 1 to 2, and 2 to 3. So our particles count up. So we know if a particle is on this line, if it's between 0 to 3, let's say 0.5, we know that it's on this line because we floor, which returns 0, and we seal, which returns 1. So we know that it's on this line, so it's getting 0 and 1 with the get functions. And then the fractional part, the frac, that we plug into the lerp says, okay, your position is now on 0.5 on line from 0 to 1. Now let's take another example on the last line. So let's say as we're counting our normalized execution index up for our particles, we get to, let's say 2.7. So we have a number that falls at 2.7. So we know if we floor, it's getting 2. If we seal, it's getting 3. And then we get the fractional part, which is 0.7. So we know it's about 0.7 on the line. So it's going 0.7 in the loop. So it's getting 0.7 between the 2 and the 3. And then it's reading those two positions and placing itself accordingly on the line. If we save that, come back and just make sure once we've saved that and saved our scratchpad here, we can rename it to sort of line-based array, or probably a better name would be something like line from array. And we get the user exposed positional array here, plug it in here, and we save that and compile. Then we can come back out into our level. So now that our construction script is already set up, we can come over to where it's exposed that position array or the vector array. We can add an element here, and let's just grab the first cube here and we can go copy, and then we go say paste, then add another, and you can see once we've added that second point, now it's looping between between our 0th point in the array and 0, 0, 0 in the world. So we can grab our next box, copy that here, and plug it into our array. So now we're looping from 0 to 1, and we can go through our boxes, copy and again paste, and again copy the next box, add another element in our array and paste, next box, copy, and then another element, paste, again copy the box, copy here, another element, paste, and this last box here, copy, another element, and paste. Now we can do this for as many boxes as we need. If we come in, play the game, now you can see that our line goes between every box that we've put, or the position from every box that we've put into the array. So this would be really useful for like a waypoint system or sort of a box system, if you want to keep the player within sort of an area, if we can, but we need to make the area with say as many points as we need, or however many walls we might want to do, or maybe like a fencing system. You can see that it's not dynamic, so we can move each box. It's just the position of the box. If we wanted to have it move with the boxes, we would need to get each box every tick and sort of update the position of the box when it moves, the position in the array relative to the box's movement. But for now, that's fine. So I hope this was really helpful. If you don't understand, feel free to ask questions. I've put a link to our Discord below. We're going to post this, and we've got all the other content that we've got from our other tutorials in there. It's all for free. If you get stuck as well, feel free to just ping me on Discord and ask for help. I'm more than happy to help. If you've got any comments, questions, let me know. Leave a like and subscribe. And this is Jordan from VFX Vault, and thanks for watching.